My name is Tejas. That's pronounced like contagious for those of you who have a little bit of trouble with this exotic Indian name. And actually, it does mean sun, like ray of sunshine. I don't know how you knew that, but you know, the MCs do background checks, I'm convinced. Which I signed a form or something, it's fine. But today, anyway, we're not here to talk about me, we're here to talk about REST. How many of you have heard of REST? How many of you use REST? Okay, that's the whole room. Whoa, that's surprising. We're here to talk about REST and GraphQL and stuff. And in our time together, what I want to show you is, I thought long and hard about it. What I really want to show you is that constraints can be really beautiful things. I think that's, in a nutshell, what I want to show you. And I thought about the best way to do that. How can I communicate in a way that, will not have you like scrolling through your phone or falling asleep. I saw some of you asleep in a previous talk. I want to talk to you in a way that engages you. And I think the best way to do that is to tell you a story. The story starts where all great stories start, and that is with JavaScript. Okay, and we had a code base at my previous employer. It was a really good product. People really wanted it. People were paying for it. We had, it was good. It helped the company even make profit. But what ended up happening was over time, the code became stale. It started to get a little bit old, which eventually led to, old code. It led to stale code. And because it was JavaScript, it just kind of stuck around. How many of you know what I'm talking about? Like, you're sometimes afraid to delete your code because, oh my goodness, I might break something, right? You're afraid to rename, you're afraid to refactor. And if you build software, we saw from Max this morning, make it work, make it right, make it fast. But how can I make it fast? How can I refactor if I'm scared to break stuff? And that's where we found ourselves. We were feature frozen, but kind of without our choice. We're really afraid to make changes. Now, how do we help this? Thankfully, there's technology that makes JavaScript scale a little bit better and makes us a little bit more confident. And that, I believe, is TypeScript. We decided, okay, we can't build on this thing anymore. This monolith is a little bit hard to maintain, so we'll recreate something and we'll try and do it right. We'll try and do it with TypeScript. Okay, and what that led us to I'm speaking faster than I can think. Happens. But what that led to was our code ended up scaling really well. Like, all of a sudden, we saw so many benefits from the static type analysis that TypeScript gives you that we could confidently delete code. We could confidently refactor. Our documentation was on point. And some of you are skeptical. I'm looking around the room. Some of you are going like, oh, he's talking about TypeScript. I'm leaving. Stay, because I'll show you practically some of the benefits we got from TypeScript. Now, I think it becomes exceedingly clear in the area of design systems. How many of you have a design system, work with a design system? A lot of you. And it's good. And if you have a design system, it's a library, meaning the API is something that's important. Like, if you want people to import it and use it, you want to expose an API that is, we say it's idiomatic, it's approachable, you're used to it. Our API documentation is generated and exposed using this tool. It's called React Style Guidist. Actually, the author of this is here somewhere. Go say hi and tell him good job for me. He's a very talented person. And I'll just show you some ways that TypeScript gives us benefits right now. So we're going to exit out of this. I'm going to mirror my screen, which I should have done before, but I was busy socializing. It's a conference. All right, there we go. Okay, so this is our design system. It's called Operational UI. And it looks very simple, but here's where TypeScript really helps. If we go to, say, avatar, okay? These are some names. This is kind of like a Google Gmail type of avatar thing, which generates a circle with initials. Okay, that's the avatar component. And it's something we use across our app. You probably do this in your design system as well. What's really important to us is the API. So I click this view code thing, and what I see is an interactive code playground. So I can go in here, I can see what it looks like with different names, and I can see it update in real time. Right? Vivek is a good friend of mine sitting right here. And so you can see it kind of update in real time. What I want to show you is how the API documentation can help. And how we do that through TypeScript is this way. TypeScript exposes type declaration files that give you powerful features in your IDE, like auto-completion, like type analysis. So if something's not compatible, you get red squiggly underlines and you know it, okay? What we have done in the documentation here, literally just for fun, just a hobby project, was we took VS Code, the engine under it, so Monaco, it's called the Monaco editor, and we kind of put it in the browser. And we fed type declarations into it. And so if I go here, look what it says. It says press Alt space inside a component for available props and documentation. I'm going to do that. So I press this, and these are the props that are available to me. Okay. And in order to fully appreciate this, look, I could go color, and I could say red. Bam, red. What else is available to me? I can say I want to hide the initials. I don't really know why. Okay, there we go. It hides the initials. We just have a red circle at this point. And I could say I want it to be huge, but look, I can't get a 4,000 pixel radius. Why? And I have intelligent documentation here. It's because, oh, I'm only expecting small or medium. And so surely enough, I can go here and say, okay, I want medium. Bam, it's done. So TypeScript is able to give us auto-completion and like next level documentation that we can't get any other way. And the cool thing is, because of Style Guide, all of this is just generated from Markdown. like we don't really do any work. We just write text files. Let me show you. So if I go here to GitHub, it's open source. You're welcome to go look at it. Contiamo/operational UI. We go to source, and I can go to avatar. If the internet lets me. There we go. So avatar. Thank you, whoever just went off the Wi-Fi. And what we see is this Markdown, this title and code snippet, is exactly the same, 1-to-1 as this. It looks a little bit different, but the true fact is that this is generated automatically from this, okay? We write text, it comes to life, and then it comes to new life with TypeScript. Very exciting. And because of that, we've seen our apps be bulletproof. Now, I don't have the time to go into the details of how we were able to do this. I did do a talk at React Finland earlier this year with more technical details. It involves simulating a file system in the browser. It's a lot of fun, and I'd recommend going to look at that. But that's not why we're here today. We're here to talk about REST, GraphQL, and TypeScript. So we're in the middle of a story, and in the story, we've adopted TypeScript, and we're seeing benefits. I mean, those are benefits, right? We took it further. We turned all of the strictness settings on. Everything was red, and then we made it not red, and we have just amazing scale. Our apps were effectively bulletproof. Honestly, nothing broke them. We'd get no emails from Sentry except in one place. And this is not an email, but this is an incoming packet. Our apps would break at the network layer. Okay. Robin did a great talk about IOTS earlier, where that's the scary zone, the IO layer. And so we would receive things from the back end that were unexpected, and what would happen? Cannot read property something of undefined, right? Like it's the JavaScript nightmare back again. And so our backend would send us these mysterious things sometimes, and this is no disrespect to the backend team, it just happens. Sometimes people are offline, which eventually made our apps blow up. Which made us very sad because there were bugs. And so we were like crying about this. We were like, okay, our apps are bulletproof, but if I see another network-related error, I'm going to be very, very sad. And that brings me to the point in the story where I just want to tell you REST is many things, but unfortunately REST is just not that good. Okay? And this is maybe a controversial opinion, especially because so many hands went up when I asked. But look, we're engineers. We don't just say something's not good. We say it's not good because there's a magical word in engineering. Let's substantiate this claim a little bit. REST is just not good because, well, for one thing, it's not a formal specification. Like, show me a formal specification for it. There isn't one. You know what that means? That means it leads to a lot of guessing games. Oh, this should definitely be a put, not a patch. But why? This is a is it a post? Is it a put? So here's a question, right? Someone requests a resource on your extremely secure blockchain backend, and they're not allowed to see it. Now, do they get a 401? Do they get a 403? Do they get a 404 because they shouldn't even know it exists? what you're doing right now is you're guessing, because this isn't documented anywhere, and this happens way too much. Or how about this one? Something doesn't exist. What status code? It's always complicated. And ultimately, my problem with this, and I am angry. I'm just kidding. It's act. But the problem I have with this is, as engineering teams, we have a lot of meaningless discussions. Should this be a put? Should this be a patch? I don't care. I want my users, our users, to benefit from our amazing products. I think we all want the same thing. Fundamentally, the issue with REST is this: there are no contractual agreements between front end and back end. You could document stuff. Sure, there's ways around it, but fundamentally, that's where we're at. I think I can best summarize all of this with this message that actually happened, though the time is a little bit off. This happened at some point. There was a conversation, and I had to ask this. Wait, so put creates something, but I thought put was for edit. And my response to this is just, okay, but like, why? Why can't we have a better way? Thankfully, there is something called GraphQL. How many of you know GraphQL, use GraphQL, love GraphQL? More heads than rest. This is a very good thing. GraphQL, I would say, my friends, and I'm happy you agree, is very good. Okay, and is very good. We're engineers. We don't just say this stuff. What's the magic word? Because it's very good, because basically the opposite of the REST points. It is a formal specification. If GraphQL is one thing, it is not some type of paradigm for client-server communication. It's not a protocol. It is a spec. It's just a specification. And for me, this is a huge deal. You know what that means? That means there's no guessing games. That means you send a post with a data and you get back something. It's specified. And if you find something that you're guessing about, guess what? Guess what? If you find something that makes you guess, you could open an issue. You could contribute a solution back to the spec, and then it becomes the specification, and you help a huge chunk of the world. That's incredible. And for me, the biggest value is that it leads to really meaningful discussions. We're no longer talking about, oh, what is this status code? Oh, what verb is that? Put, patch, post, delete, update. And update's not a verb. No, we talk about, can we cache this? Can we reduce the size of the page? Can we do things that affect the user in a positive way? That's why we build software, and GraphQL makes that up and center, front and center. And lastly, GraphQL gives us really strong contractual agreements. You describe your schema, you say, hey, these are my things, they live here, and you establish this contract for your API. And for these reasons, I think GraphQL has a lot of value. But you know what? This is just the developer experience stuff. This is like cross-team stuff. If we were to talk about the user experience benefits of GraphQL, we would have to go like off the screen, like, right? And you laugh, but it's the truth. It's the truth. So I think I've made my point. GraphQL is very, very good. Now, I was at a I was here in Berlin. I was at a conference, actually with my coworker Fabian here, and we there was like a talk about how to convince your boss to adopt GraphQL. Apart from showing them this talk, this is a problem people had. They were like, okay, GraphQL is amazing, but nobody sees the whole picture. How do we convince people? And in this talk, there was this notion of this conversation being had a lot. Somebody says, hey, I want to add a GraphQL service to our stack. Mr. CTO, Mr. CEO, whatever. And the response is, well, we can't because reasons. And the top reasons were really, I don't get them. Again, here's that word, because. You want to take a picture? We can go back. Let's see. Back too much. It's okay. You can just interrupt my presentation casually. It's okay. Good. Okay. So because they say, well, we don't trust JavaScript for an API. JavaScript, it's a toy language. You use it to make like clocks and counter demo to do MVC. Come on. You don't use it for an API. We already have an API team and they have tasks. If you don't believe me, just go look in Jira. Oh, what's that? Jira doesn't work? Oh, sorry. Okay. Or how about this one? This is, we just don't have the time for that. Hey, Agile, Scrum, it's meetings, committees, so we need to ship. We need to ship. The problem is when you laugh because you relate, but when you have this culture, you ship things that the user doesn't like. You know, you ship things that cause runtime exceptions. You ship things that break at the network layer. And I've experienced this firsthand. And so all that to say, my response to these reasons is this. But at some point you go, okay, you know, let's make it work, it's fine. But then your entire team goes, okay, well, and so what is the solution? How can we, is there hope for us stuck in the land of rest? I think so. So this is where we find ourselves in the story, okay? You have a constraint, and the constraint makes you sad. You could either just kind of wrestle with it, you could fight, you could do politics, you can backbite, you can whatever you want, or you could say, hey, it's time for a side project. It's time to innovate. Constraints can drive innovation. You can tweet that because that needs repeating. Constraints can drive innovation. I was heavily inspired by the Apollo project around GraphQL. For those of you who know it, I mean, it's incredible. They have client, server, and it's just stunning. And it's mostly TypeScript and the APIs. And I could talk all day about how amazing Apollo is. So that inspired the creation of a similar library. So I made a library on a Saturday. We call it Restful React, and it's not some variant of React. Just naming things is hard. It's just how you fetch data in a predictable way, more or less, with React in REST. And apart from like talking about it a lot, I can show you some demos of Restful React. So let's go here. I'll open up my editor. He's offended because I said REST is not good. I'm just kidding. So we have this. This is my app, and it says, "Hello, React Day Berlin." But this is kind of not really fun for you, so let's do something. Let's open a browser. Let me just actually yarn start this bad boy, okay? And I will open a browser here, and we'll do split screen. So, okay, and there. And so what we'll do is we go localhost 8080. I believe it's running there, and it's what you'd expect. It's a React app, nothing special, just hello React Day Berlin with a lot of fire and metal signs. How Restful React works is you wrap your entire app in a provider from Restful React, and you need to kind of give it some context to tell it like, hey, I'm talking to this service, okay? So I'm just gonna. You've probably done this with a lot of other things. And now it's red. Why? Because TypeScript's saying, no, I can't. I need a base prop. I need to know who you're talking to. So base equals. We will talk to my favorite API in the whole world. Okay? This is the dog API. Absolutely love it. Dog.ceo. And so what we're going to do, our app will not change at all because, well, nothing changed except we added some context. So we'll go in here, and we'll use a React hook. It's called useGet. So I will import. I don't even need, look, TypeScript will give me automatic import. Const, I'll destructure something, and I'll use get, okay? Bam. And I will say I want stuff from the dog API. I want breeds, image random. I believe, apologize if this doesn't work, but I just want a really good dog on the screen. And I get data. What else do I get? I get, am I loading? And I get an error, okay? Oops, okay. And so now if I'm loading, I want to say huge, like, hey, I'm loading. If I have an error, I want to just log, I guess, the error dot message. And lastly, if I have data, I want to img alt, always use your alt, good boy. And we have data dot message, I believe. But see, notice this, I'm guessing, I don't really know this message thing exists. And if I look at what data is, it's anything. So this, let's see if that works. Okay, it works. Great. But the problem is, and this is kind of why our app was breaking, I could turn message into like massage, right? And then, of course, it doesn't work. Everything breaks. Oh, no, it's on fire. We can't ship. So how I can fix this is using generics and TypeScript to kind of mock the shape of my backend response. So I go here and say I'm expecting something with with message as a string, okay? And now it's like, okay, fine. Message, no. Message 3, no, whatever. Doesn't really exist. Doesn't exist. It wants data dot message. This is fine. This is already a good way forward, and it's working, and that's pretty great. So that's an initial RESTful React, and it works really nicely, right? Would you agree? Would you disagree? It doesn't matter. I have the microphone. But can we do better? let's revisit. So we said REST is just not good because, and we went through the reasons. We won't do that again. We'll just look at them again because I feel the pain of REST still. But that last point, no contractual agreements, is kind of sort of malleable. You kind of bend that a little bit because there are some contractual agreements. You see, our backend was implemented in Golang. I can't say if it's a good language or not. I was going to say it's a great language, just my nature, but I don't know. And so the APIs are, it's strongly typed. The APIs are documented. And so my amazing coworker, Fabien, I took this picture today, sitting right here. Give it up for Fabien, everybody. Stand up. So Fabien, what he did was he wrote something to go to the Go source code and pull out TypeScript definitions. It's amazing. It's a great tool, full of regular expressions, but it really works. We were inspired by this to go, can we actually do this? And so we looked into OpenAPI. Now, OpenAPI is an evolution of Swagger. Okay, and it's a way of describing your backend response or your backend API entirely, your REST API, post, put, patch, get, delete, and all the status codes and everything in YAML or JSON. And we were like, okay, well, this gives us an idea. Whoa, there's something here. Problem is, unlike your GraphQL schema definition, these things are big. They're very big. And so we worked with them a bit. Fabien read them, and he was like, okay, I'm reading this once and probably never again. And so can we somehow use this? Specifically, can Fabien somehow use this? Sorry. So he had the idea for code gen. He was like, okay, we have information. Let's see if we can generate some stuff. And that is what we have today. This, I need to preface, this allows for something really innovative and a huge advantage from GraphQL that we now have in REST, my friends, and that is end-to-end type safety. And I'd love to show that to you now. So we're going to go back to our split screen, and we're going to talk to a different API. So we're going to go here, and instead of talking to dog CEO, as much as I love it, we're going to talk to API. How do you say it, Giphy or Jiffy? Giphy. I heard Giphy first, so we'll go with that. api.giphy.com/v1. And of course, this is going to break. We're going to see nothing. Failed to fetch 404. Expected. And we're going to do something. So Restful React exposes a CLI, okay, as well. So command line interface. There's a great lightning talk on those by my friend Shahrukh. And how it works is this. You say yarn Restful React, so you access the binary React, and you import you could import it from a file, and what it expects is an OpenAPI or Swagger document, okay? You can import that from your file system, from your hard drive, from wherever, or if you want to be fancy, you can go, okay, this lives on GitHub. So you can literally just it will go to GitHub, fetch the document, and come back. And you fill out your GitHub username, the repo name, the branch name, and the file path, and you tell it, hey, I want to output this here on my file system. Okay, and I will hit enter, and it's going to go off and get that stuff and done. So it executed in 1.53 seconds. And if I look here, oh look, it's a green file. I have a new file. You want to look inside? Let's look. So it's a whole bunch of types, and we don't really need to concern ourselves with these because it exists. We can use them. Okay, shall we try? Let's try using it. Let's fetch some data from Giphy, Jiffy, Iffy, whatever, and see if it works. Now, we did loading error in data, so we don't really need to change that because it's the same RESTful React, it's the same API. So I'm going to remove this import from RESTful React, and this is going to yell at me. Yes, I know useget doesn't exist, but we're going to instead import something from our API. So I'll import something from /API. Now, RESTful React takes API documentation and gives you React hooks. We need to find something in this huge ocean of stuff. How do we find hooks? Use. So we type use. Look, these are the things that are available from Giphy. We can just access them. So let's try and get a random GIF. Okay? No more use get, but use random GIF. We don't need this generic type anymore. It's fully type safe. It knows it doesn't expect a path. It actually just expects an MD object. And look at this, end-to-end type safety. It's like message doesn't exist. That's incredible. Okay. Instead, what do I have? I have data dot. Okay, well, I guess data again. Maybe I should rename data to like GIF response, just so I don't confuse myself. Okay. But it's not a string. It doesn't go in the image, so I need something else. Dot images. And look, I have this auto completion right here. I haven't left the editor. Dot original, I believe. Dot and then lastly the URL, which is a string. And now my SRC is satisfied. I have some optional chaining going on, which is stage 4, by the way, in JavaScript. Yeah, that's right. And save, and what I should see is a error, 401, because I am not authenticated. Now, I need an API token, and Giphy does this via query params. I don't know why. I think it's not really safe, but okay. Pretend you don't see my token. I will revoke it after the talk. I'm just going to copy this token, cowboy style, and we'll say query params. API key is my API key. Again, I will revoke it, so if you want to abuse me, just wait. And just like that, we have a full-on random GIF from the Giphy API with end-to-end type safety because of Restful React. I think this is absolutely incredible. And here's the thing, I could swap that out for an array of GIFs for whatever, and it just works. That is incredible. So, thank you. It's like one person back there. So let's wrap this up. I think that's absolutely incredible, and that's a powerful use case that's enabled in React via TypeScript and code generation. And so we have some of the benefits from GraphQL in React. Let's switch to the takeaways. I'd say number 1, constraints are your friend. We started the talk this way, and I'll finish the talk this way. If you have a constraint, you can get bitter, you can say stuff, you can whatever, but I would recommend use it to your advantage. Build something. Fix the problem. I believe you can as an engineer. Types are your friend. Auto-completion, syntax, safety. It's your friend. Nothing is really that impossible except maybe, some stuff, whatever, but it's supposed to be inspirational. Go with it. And lastly, I'd encourage you to get creative. And with that, I just want to say thank you very much for having me at React Day Berlin. But hang on a second. There's just one more thing I want to mention. So we're almost at the end of the day, and the slide's not up. Okay, whatever. Thank you. We're almost at the end of the day, and I have noticed, the volunteers have been doing some amazing stuff. They've been serving. You may not even notice them, but the people behind the scenes make this conference work. And I want to take just a moment and point out one of them specifically, Conchita right here. Will you stand up? You deserve, if you don't want to stand, Conchita right here. I have gotten to know the volunteers, and I'd encourage you, like the person who hands you your badge or something, get to know them. They're incredible people, and they make all of this happen. So anyway, thank you very much.